our injection timing. So we're going to have what's called a boundary, and we're going to have a normal. And what we're going to find here is that the boundary and the normal add together to give the specified time where we want to spray our fuel. Now here's what gets confusing. We're referencing this in end of injection timing. So when we're looking at a normal auto cycle, we're going to be calling top dead center between our exhaust and intake stroke 0 degrees. And then we're going to be moving forward from there. With end of injection, it's actually going to be backwards. Everything's going to be opposite. So we're looking at our compression and power stroke. That's going to be at the TDC point there. That's going to be 0 degrees. You can think of it kind of like spark timing, where we're referencing our spark timing at 40 degrees before top dead center, and 0 degrees would be that top dead center point. Now, when we're talking about injection timing, we're going to be counting backwards from that point. So we're going to go backwards, and it's going to be positive degrees going backwards. So when we're going from 0 at that TDC point between compression and power stroke and going to the TDC point between intake and exhaust, that's going to be 360. And that's what these tables here are going to reference. So it's called end of injection. So it's going to be using the start point of injection as a reference between the TDC, between the power and compression stroke, and going backwards and timing where it wants the injector to end, which is essentially where it wants the injector to start. That's what's confusing here, is at that 360 point. So these two values here add together, crunching in some math, and it's going to spit out in crankshaft degrees what we want the injection time to be at. Now, these values here that we're looking at between the boundary and the normal table, these values are based around a stock camshaft. So we want to have our fuel spray onto ideally on the way GM has this design, it sprays onto a closed intake valve. On a closed intake valve, the valve is hot. It's going to be going in and vaporizing that fuel that we're spraying in there. And when the valve opens, it's going to get into fuel into the engine. It's going to give clean emissions and have a balance between the emissions and the power. So it's how GM times things. Now, when we go and install a larger cam, our intake valve closing point, or intake valve opening point and closing point change. Our exhaust valve opening and closing point change from a stock cam. So everything gets thrown off. The biggest problem when we install a cam is that we're going to have our exhaust valve typically open longer than we would when we have a stock camshaft. We have more duration. That exhaust valve hangs more into our intake stroke compared to what it would be on a stock camshaft. So in that situation, if we're running these normal values here, the boundary and the normal, the combination between these two, we're going to find that as we're going in and we're going to spray the fuel into the engine, we're going to be getting it going in and spraying against an open exhaust valve, where we'd ideally like to have the exhaust valve closed so that we don't have to worry about spraying fuel right out of the exhaust. And that's actually when you install a cam. And even though if your wideband registers and reads a good air fuel, let's just say it's reading stoichiometric or 14.7, you're saying, man, this thing stinks. It doesn't matter what I do to the fuel table, it just always smells. That's because the wideband is only metering and measuring the combusted fuel. If you have your injection timing wrong here, if you have it timed at the wrong point, you're going to find that you're going to be spraying raw fuel out of the exhaust, creating that really strong fuel smell, also going in and wasting fuel just during normal driving. You're going to be losing some economy. So timing this is going to be desirable. And the way I go about timing this is based on the exhaust valve closing point. So again, when we have our aftermarket cam, our exhaust valve closing point is going to be different than a stock. And we're going to find these values give us a certain amount of crankshaft degrees. If again, we're referencing going from 0 degrees, going back 360 to TDC between exhaust and intake valve events. And then usually we're going to find that it's going to be spraying here right around or right before that point where it's going to be at that 360. Usually it's going to be pretty shallow. We want to go and move that point up. We want to go and delay it a little bit. So let's go in. I have a spreadsheet here. This should make a little bit more sense. Let's jump into our spreadsheet so we can take a look. So in order to utilize this, we're going to be copying our stock values from our file, which could be different between different operating systems and different files that you're working with. We're going to have our boundary stock and our normal stock. We can see these are the values in the table here. So I simply just went in, just for illustration purposes here. I went to my boundary. I just copy this at 6.5, paste it in here, into my spreadsheet, paste it into my spreadsheet. So just copy paste. You can copy and paste between these two. There's nothing complicated about it. So I'm simply copying whatever the values are in my stock file. Again, you don't want to have working with modified values. These need to be stock values. So in your stock file here, simply copy, simply paste. So we copy and paste. Now, what we're going to find here down at the bottom is the end of injection time in crank degrees. So I've taken the values here. I'm taking the accumulation between our boundary and our stock. The accumulation of that.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.